Hello folks, welcome to another one of our Vapor Chief Before You Buy videos. In this video I want to continue the discussion about pressure and the reason why we can increase the pressure on our machines and do it in a safe manner and make sure the machines are still heavy duty and they'll hold up to everyday use. Now again, we're not saying that the competitors don't use heavy duty components, and one of our competitors is saying that we use what everybody else uses. Now that's partly true, but it's really not true. Because even though we're sourcing some of the components from the same manufacturers, we're having certain components specifically made for us. And that's what I want to show you here, because there's a lot of things that go into building a steamer. Now, let me preface this by saying this could get a little bit boring, because if you're not into technical talk and you don't want to talk about parts and electronics and all that kind of stuff, then maybe just kind of hang in here for another 30 seconds and go on to the next video. But if you're interested in, and I'm not going to show you how a steamer is built, but I want to show you some of the things that go into it and why our components are as heavy duty or more heavy duty than some of the other machines that are out there. Now, as I said, that as we start to get higher in pressure, now let's discuss pressure between what we have in the United States or what United States customers want and North American customers want compared to European customers. Now, in Europe, everybody's working at 240 volts. 240 volts means that they can put a higher wattage heater inside the machines, which means the machine's going to heat very fast, it's going to hold its pressure very well, and it's going to recover extremely fast because of the higher wattage heater. They're also using less amperage. When you go to 240 volts, you're not pulling as many amps. So those machines run cooler, they're not under as much stress. So the Europeans, they've always had the philosophy that you don't need as much pressure in a machine because you're working at a constant pressure. So if they design their machines for 4.5 bar, which is somewhere in the 60-65 PSI range, that's what you're getting. That's how they brought them over to the United States to begin with, because they were used to working at those pressures. But now in the US and North America, we're working at 120 volts, which means we can only put maybe half the wattage that they can in Europe. So we're going to see a higher pressure drop. We're not going to see a machine heat as fast. We're not going to see a machine recover as fast. So a machine that starts at 65, you're going to get a very quick pressure drop. You're going to get low working pressure, and that's what some people just don't accept, and they don't like it. And that's the difference between our machines here, because we're at 120, and the European machines. So now, as we've gotten into higher pressure in the United States, that's caused some problems with some machines, whether it's who's ever making the machines and jacking up the pressure, whether the customer is doing it, whether they figured out a way to do it, or whether the manufacturer tried to increase the pressure. The increased pressure is putting more stress on the US and North American machines, because now we have more heat inside the machine, you're leaving the heater on for longer, that's creating more pressure, that's putting more stress on the components, and we're under a higher amperage. So that's causing a lot of resistance and a lot of heating of the internal wiring. So when you're making a machine and you're calling it commercial and people are using it every day, such as in the detail field, the field that I know better than anything else, when these guys are using these machines for 8 hours a day, 5-6 days a week, that's putting more stress on a 120 volt machine that you don't see in Europe. So again, if I'm making a machine at 100 PSI, our working pressure is going to be maybe 65 to 75 based on the pressure drop, because we're at 120 volt. In Europe, if they're bringing a machine in at, say, 65, maybe 70 PSI, because of the wattage of the heater in that machine, you're going to hold that pressure very, very well, and that machine is still going to work at around 60 to 70 PSI and hold its pressure very well and recover almost instantly. So that's the difference, and that's why the Europeans didn't want to make machines for the US market at higher pressure, because they were used to making them at a lower pressure. Now myself, again, being in the detailing field, I always wanted a machine at higher pressure. Higher pressure machines work better because we need them to dig into car dirt that homeowners might need to do, or people in other cleaning industries that are working on hard, non-porous surfaces. They don't need quite as much pressure. But what I found in the detailing field is that we want higher pressure machines, but making a higher pressure machine comes with its own problems, as I just explained. So that's the difference, and I kind of got off track, so I'm going to end this video here, and then we'll talk about the components in part 3 of this. But that's why now the US market is craving and requesting higher pressure machines. But to do that, we have to make the machines a certain way. We have to meet certain requirements. We want to make the machine safe to satisfy the US customer and to give them a higher pressure machine and a good working pressure as they use it. So Hang in there for video number 3. We'll talk about the components, and then if you get bored, you can kind of scoot out on that video and look at other videos. So we'll end it here, and part 3 of the pressure series, we'll talk about the components.